All right, so this is the second day of the review for the expressions and number properties test. So we talked about how an expression is a basic math phrase that has numbers, operations, and sometimes variables. So we looked at different types, we looked at writing expressions, and sometimes you're asked to simplify. So simplify means that you either, if it's all numbers, you plug it all in your calculator and solve. If you have variables, there's two main ways we can do it. We can combine like terms, and we can use the distributive property. So in this problem type, we have the expression 15 minus 2x plus 9x minus 8. Now, when you're combining like terms, you're looking for individual parts of the problem that you can put together called terms. So I've often boxed off the expressions so you can kind of see them in kind of cards. And looking at these two, the x terms we can combine, they're like cards. So we would say negative 2 plus 9, and that would give us an answer of 7. And our variable x comes along with it because that's what makes them like terms. So that would be for my x boxes. I have 7x. Then if I look, I also have regular constant numbers, just regular integers. They're 15 and negative 8. I can also put those together because, again, they're regular numbers. So 15 minus 8 is going to give us 7. So putting these two terms that I got for an answer together, we have a 7x and a positive 7. If I look at my answers here, A is the one that has the correct terms there, 7x plus 7. Okay, we can also, again, simplify expressions that have multiplication, and we can use the distributive property if you have terms that are grouped with that multiplication. So we've got a single term out front of a grouping. That's the key characteristic when we use distributive properties. So we take our negative 2 and we multiply it by the first term. So negative 2 times 5y is going to give you negative 10y. Then we take that same term out front, negative 2, and we're going to multiply it by the back term. And guys, we've talked about that we, again, include that sign in our multiplication. So negative 2 times a positive 7 is a positive 14. So again, putting these two term answers together, this is a positive 14, negative 10y, and a positive 14. A is your option here as well. Okay, looking at number 13, this requires both of those skills, distributive and combining like terms. So when we have both, we're going to use the multiplying first because order of operations tells us we do that first. So this is the portion of the problem. Again, a number right out front of a grouping bracket. So this is our distributive portion. So we take that positive 2 and we multiply it by the first term of x. We get 2x. Then we take that 2 and we multiply it by the last term, a positive 4. And again, looking at taking the sign along with it, we get an answer of a positive 8, so or plus 8. Then from there, remember that 12 that was just kind of hanging out front, we're just going to go ahead and put that. Now you might also notice we need a sign in here. Terms are joined together by sign. So it was a positive 2x when I multiplied here. So a positive can be put in there to, again, connect all my terms together. From there, combining like terms, again, it's like those little boxes, the positive 12, the positive 2x, and the positive 8. So looking here, my regular numbers, 12 and a positive 8, I can combine. That makes 20. And that green positive 2x here in the middle doesn't have anyone to combine with, no other cards with an x, so it just drops down. So looking here, B would be my option. All right, so we've done 11, we've done 12, we've done 13. So you also might be asked to evaluate. So simplify the following expression. Oh, sorry, this is still a simplifying one. So this is another one where we have both put together the combining like terms and distributive property. Here's my multiplying portion. So we're going to start there. 5 times x, 5x, 5 and a positive 2. Again, we are multiplying, so that's a plus 10. And that negative 3, we're just going to pop it on down. It was kind of hanging out there in the back. From here, looking at like terms, again, if I box off all my terms, positive 5x, positive 10, negative 3. You should notice my 10 and my negative 3 are the like boxes this time. So 10 minus 3 is a 7. 5x is just a term that I'm going to drop down. And again, I need a connector there. So ask yourself, was that 7 a positive or negative? It was a positive answer. So 5x plus 7 is your answer. We're going to take a look at 15. Sometimes we're going to be asked to evaluate. So here's our expression. and we're going to be evaluating it is for the value of 10, if x is 10. So we're going to take out our x here, and we're going to put a 10 in there. That's how we evaluate. We plug in the number value. So following order of operations, this is down to a numerical expression, which we can put in our calculator left to right, and you get the answer of 12. All right, so 16 here is just a reference to your number properties. So we talked about 4 different number properties in specific. So we just kind of looked at number 4 about the distributive property, multiplying an outside term by both or all terms inside of a grouping. We talked about the identity property, which just basically means for addition, it's a plus 0 keeps the identity of 8 the same for your answer. For multiplication, in order to keep 10 the same and have it be your answer, we would need to multiply by 1. So the identity property is the addition of 0 or the multiplication of 1 keeps your number, the original, the same. And we looked at 2 other ones, the commutative property, which is for addition and multiplication, and the associative property, which is only, again, for addition and multiplication. So commutative property is where you can flip the order of the numbers. You can, take 4 and we add it to 5 and we get the answer of 9. Or we can flip the order of our terms again and say 5 plus 4, and you're going to get the same answer of 9. Again, it works for multiplication. 3 times 2 is 6, or 2 times 3 is 6. Again, so you can flip the order of the numbers and still end up with the same answer outcome. And then the other one we looked at was the associative property, which is that you can, if you've got more than 2 terms, you've got 3 terms, you can group numbers differently, again, only with an addition and multiplication, group differently and get the same answer. So if we look here on the left, 3 plus 5 plus 8. If I look on the right, we have 3 plus 5 plus 8. Take a look, 5 and 8 are grouped in the first set, and 3 and 5 are grouped in the second set. So again, the order didn't change. I still have 3 numbers and they're in the same order, but the grouping changed. Same thing you can do with multiplication, and again, your answer or outcome does not change. So those were the 4 definitions and the 4 properties we looked at specifically. So looking at 4 problems that deal with it, using the associative grouping property, which one fills in the blank correctly? So again, remember we talked about grouping, the order stays the same of our numbers, and just the grouping or parentheses goes around a different couple. So if we take a look at our options down here, again, the first thing we need to look at is the order of our numbers stay the same. So A is an option, 5, 6, 7 is the order, 5, 6, 7 is the order for A. If you look at B, it switches the order, so that's no good. And same thing with C. My order of my numbers are out of whack. So my order is the same for A, and my groupings are different. Up here in my example, 6 plus 7 are grouped, and down here below, 5 and 6 are grouped. So A is the correct situation. All right, so taking a look at another one. The commutative property allows you to switch the order, again, of your addition or multiplication without changing the answer. So which example below shows this property? So again, we can switch the order of our numbers, and we're going to get the same answer. So we're going to be comparing left to right side. So here's my first side, here's my second side. Did I switch the order of my numbers? No. 2, 3, 4, 2, 3, 4. So A is not it. If I look at B, on the left, I have 2 plus 3. On the right, I have 3 plus 2. So check. That one actually does switch the order of my terms and would therefore be my answer. All right, if I look at number 19, which of the following is an example of the identity property? So remember we said identity property is when you keep the original number the same for your answer. And there were 2 specific ways we did that. For an addition problem, we add 0 to keep the identity. And in a multiplication problem, we multiply by 1 to keep the identity. So going back to look at our problems, looking through option A, B, and C, I actually made a mistake. Both A and C are actually an example of the identity property. A is my multiplication, and C is my addition, but both are actually correct in this scenario. All right, last question, guys. Which is an example of the distributive property? So remember, that is when we have a term right out front of grouping, and it indicates multiplication. So if I look at A, we do have a grouping, and we do have a number out front, but the operation in between is an addition. So not it, because we know distributive has to do with the operation of multiplying. If we look at 2, or I'm sorry, B here, we have a 2 right outside of our grouping. When they're buddied up like that, we do think of multiplication, so B would be your correct answer. Just to kind of take a look at C, a lot of times students are stumped by this and they pick C because there is a term right outside of parentheses. And yes, you would multiply there. However, that parenthesis isn't really a grouping. It's just around a single term. And so therefore, it's actually truly more so representing just a singular multiplication and not the distributive property. So again, C would not be it. B is definitely it. We've got a single term outside of a group of numbers. All right, so hopefully you feel a little bit more prepared for the unit test on expressions and number properties. If you need any more help or you want some more practice problems to review, just let me know.